before the so what's the didn't have the problem. So you have do you have the problem that I gave you last week? What's the first problem? What's the first problem? The integral of x squared plus 1 and x dx. Okay, so it's use the integral by parts, where the u is ln x and dv. So if u is ln x, then dv is now x squared plus 1 sorry, dx. So from here, we have du, derivative of ln x is 1 divided by x dx, and v is the integral of x squared plus 1 dx. X squared plus 1 dx is 1/3 x power of 3 plus x. You don't need the so the value of this integral is u v minus integral v du. So u is ln x multiplied with v is 1/3 x power of 3 plus x minus integral of 1/3 x power of 3 plus x multiplied by 1 divided by x dx. So we have 1/3 x 3 plus x, just reorder and x minus. So this one integral of 1/3 x 3 plus x divided by x dx. This is the same. So minus integral of divided by x. So it's 1/3 x squared plus x divided by x is 1 dx. So it's minus, the integral is 1/3 times 1/3 x power of 3 plus x. Now it's plus c. So we have 1/3 x power of 3 plus x ln x minus oops, divided by 9 x power of 3 plus, oh sorry, minus x plus c. And what is number 2? Square times? Eh? Oh, sin square x. Sin square, oops. Sin square x dx. Now we can use the du, right? So let's say it's u is x squared. Why? Because the derivative of c become x, and the dv is sine square x dx, and du is now 2x dx, whereas the derivative of x squared is 2x. And what is dv? V is the integral of sine square x dx, and that becomes remember the we have cos 2x equal to x squared, oops, cosine square x minus 1 or 1 minus 2 sine square x. So we have for sine square x dx, then it's become half, sorry, 1 minus cosine 2x dx. So it's become half x minus half sine 2x. So this is v, and this is dx. So the integral now is uv minus integral v du. So it becomes ux square multiply with half x minus half sine 2x minus integral of 1 x minus half sine 2x multiply by 2x dx. So we have half x square x minus half sine 2x. Oops. So why we use this one? Because we know that we can put the square becomes the power of 1. So this is the idea why I choose v. If I choose u is sine square x, so u then dv. So let's say if I choose u is sine square x, then du is 2 sine x cosine x dx. So then dv is x squared dx, and v is the x power of 3 dx. Oh, sorry. Now the power of x become 3, and we don't want because the power of x become higher. We want that the power of x become lower. Sorry. So that means we don't use this in the graph by part. We don't select u as an sine square x. So this is the so, and then minus we have you can cross this one. So it's become integral of x square minus half x sine 2x dx. Yes. Oh, sorry. Thanks. Right. Yeah. You can say that, but the problem is if you make let's say, I'm not saying it's making wrong selection, but the problem is like that. Sorry. So if you take, so if you choose u as sine square x, right? As I said, it's actually free choice, right? But if you choose u as sine square x, then du is 2 sine x cosine x dx. Then dv, because you already take u as sine square x, that means dv now is x squared dx, right? Now, if dv is x squared dx, then v is x power of 3. Now the problem is, I'm not saying that it's wrong, but if we continue this one, then the power of x become higher. The target is we make this one is lower. So become so that means if we take x squared, then du is 2x dx. So this is the power. Sorry, the power is x is lower than before, from 2 to 1. Okay, and this one dv is sine square x dx is also we can use this formula as before. So this one so that means sine square x equals half 1 minus cos 2x. Then the power is become 1. Even this one is 2x. It's no different. We just half. Yeah, it's a half sine 2x. So basically, sometimes, for example, this one, if we take u is x squared plus 1, du is lower, but we need to integrate ln x. So if let's say we take u is x squared plus 1, then it's also du is 2x dx. However, if we take u equals x squared plus 1, the dv is ln x dx. So we need to have integral ln x dx. You can say, well, what is the integral of ln x dx? You use another integral by part. Let's say this is u is du is dx. Sorry, u is ln x, and du is dx. That means another you have du is 1 divided by x, u is x. Then the integral is the integral become x ln x minus integral. But again, you will integrate the this is the 1 divided by x. Oh, sorry, the x. X times 1 divided by x dx. So that means x ln x minus x. Now the integral of that, by taking that, the integral is become the integral of, sorry, the result is u multiply x squared plus 1 x ln x minus x minus integral x ln x minus x multiply by 2x dx. So it's longer than I'm not saying that you can still continue this one. Sorry. Yeah, it's just a longer that one. Well, in integral we don't talk about efficiency. So if you want this one, it's fine, right? As long as your step is correct, even though it's longer, then it's fine. Okay, so just that one is shorter, but in integral we don't talk about whether it's longer or not. So this is yeah, the important is correct. Okay, so like this one, now sometimes longer, but doesn't go to the solution, right? This one may go longer, but maybe go to the solution, but this one longer, but it doesn't go to the solution. So that's why I say use this one. So we can use this solution minus x, sorry, then plus half integral of x sine to x dx. Now we will use this one is equal, sorry, 3, yeah. Now we use integral of x sine to x dx. Again, we use the u is x and dv is sine to x dx. So du is the x and v is the integral of sine to x dx, which is minus half cosine to x. So that means the result now is just put the integral of half x squared times x minus half sine to x minus 1/3 x3, and then the last integral is half x times minus half cosine to x. And then minus the integral because it's minus, then plus half cosine to x dx. And the last one is for sine to x. So half minus half x cosine to x plus 1 divided 4 sine to x. And this one is the same, and let's see. What's the third question? The integral of, sorry? E power of 3x. This one? Yeah. Okay. Now again, we use u as x squared, and dv is e power of 3x dx. So du, again, the power of x squared becomes 2x dx, and v is in the integral of e power of 3x dx, which is 1/3 e power of 3x. So that means the integral now is x squared times 1 by 3, sorry, the 3x minus integral of 3x multiplied by 2x dx. So it becomes x squared e 3x minus 2 divided by 3 integral of x e 3x dx. Now we use, for this one, we use the integral by part again. So u is x, then du is dx. And again, dv is e 3x dx, and v, we know that this is 1 3 e 3x. So sometimes we, and then the integral now is half x squared e 3x minus 2 3 x times 3e 3x minus integral 1 3e 3x dx. And oops, 3 x e 3x minus 3 times 1 3 e 3x plus c. But you can collect all those become half x squared and minus 2 divided by 20, oh sorry, by 9x, and then plus 2 divided by 27 and e 3x, if you want to write this one. Yeah.
What do you know when you should do the second?
Sorry?
How do you know when to do the second?
Because this one, we need integral by part again. Sorry? Yeah, because we cannot integrate. You know the formula that I gave you on the other day. It's not possible to have the solution without integral by part, right? So because the form is actually similar to the first problem. I mean the original problem. But this one is x squared, now is x. But for this, the last one we don't have x, so that means we don't use the integral by part. We just use the integral of e ax dx equal to 1 divided by I e ax. This one for, but this one also actually to integrate integral of e power of 3x. This is the same. Now we use integral by part again because this is the only way to solve this problem, right? Okay. Now take u as x plus, oh sorry, u as ln x, and dv is x plus, so du is 1 divided by x dx, and v is the integral of x plus 1 of x squared dx, and is half x squared plus minus 1 divided by x. Yeah.
Okay.
So the integral is ln x multiplied by half x squared minus 1x minus integral of x squared minus and x 1 divided by x dx. So it's become minus integral of x minus 1 divided by x square dx. So it's become minus 4x square minus 1 divided by x dx. So it's become half x square minus x ln x. Oops. Let's see. Now what happened if 1 divided by x? Integral x plus 1 divided by x as before. Oops. Ln x dx. Then again, u is 1 divided by u is ln x, and du again is 1 divided by x dx, and dv now is x plus 1 divided by x dx. So v is integral x plus 1 divided by x dx. So equals to half x squared plus ln x. So the result is ln x multiplied with half x squared plus ln x minus integral of half x squared plus ln x multiplied by 1 divided by x dx. So it's equal to half x squared plus ln x multiplied by ln x minus integral of 1 divided by x plus ln x divided by x dx. Now this one is 1 divided by 4x squared plus, now what is the integral of ln x divided by x dx? We don't use the, but we can use substitution. What is substitution? Like if u is ln x, then du is 1 divided by x dx. So what we have here is plus integral of u, sorry, u du, because this is ln x equals to ln x multiplied by 1x dx. 1 divided by x dx is du. So that means this one equals to integral half u squared. So that means the result now is equals to half x squared plus ln x multiplied by ln x minus 4x squared plus half u squared. U is ln x, so it's half ln x squared. So this is, so we still have the result even if I put 1 divided by x. But again, we have this one. So We'll come back later on. Now we have furthermore is the integral of rational function. Rational function is in the form of px divided by qx, where px and qx is polynomial. Now, before we use this one, we go to the integral of rational function. So, for example, we have the integral of, let's say, x squared plus 1 divided by x power of 3 plus 2x plus, let's say, 4 for x dx. So both are polynomial, or we have x3 plus 2x squared plus 4x plus 1 divided by x squared plus 4x plus 5, or minus 5 dx. So both are polynomial. Now, before that, there's some, let's say, formula to support this integral. First of all, we have the integral of f prime x divided by fx. I mean, the upper is derivative of fx, or with some constant multiplication dx, then is equal to ln fx dx. So, for example, if you have the integral of x divided by x squared plus 1, we know the derivative of x squared, dx, is 2x. Then we can have integral of 2x dx, half divided by x squared plus 1. Now 2x is derivative of x squared plus 1, then become half ln x squared plus 1. This is because why we have this formula, because if we say, let's say u is fx, then du is f prime x dx. So that means the integral of f prime x divided by fx dx. So f prime x dx is, f prime x dx is du. So integral du divided by u, and this is ln u plus c, then is ln fx dx. Another formula is, we have, I think I've mentioned before, but if we have integral of dx divided by x plus a square plus b square, then it's become 1 divided by b arcus tangent x plus a divided by b. So, for example, if we have the integral of dx divided by x squared plus, let's say, 4x plus 5, then we have the integral of dx. So the idea is, this is the definite positive polynomial. definite positive integral means the integral. Sorry, the root of this is complex number. So this one, the root is complex number, x squared plus 4x plus 5, because it's 16 minus 20. So we can we can change this form to this form of square. So it's become x squared plus 4x plus 4 plus 1. Because we know that if we have x squared plus 4x, to make it x plus 2 square equals to x squared plus 4x plus 4. Now we have 5, so we have 4 plus 1. Then the integral of dx divided by x plus 2 square plus 1. Then 1 divided by 1, arcus tangent x plus 2 divided by 1, or arcus x plus 2. So this is the definite positive. Definite positive quadratic function. So definite positive means the root is complex. So this is the two important now the condition that we can solve the integral of rational function the condition is that qx can be factorized maximum is definite positive quadratic function, quadratic polynomial. Maximum means you can have linear, or at most is quadratic polynomial. So this is for the condition for qx. So that means if we have, let's say, x3 plus 2x squared plus 4x minus 7, if we can't factorize into maximum of quadratic polynomial, then we cannot solve. Sorry, this is the numerator. So for example, if you have 1 divided by let's say dx, if we can't factorize this equation, right, then maybe we can't solve this integral. So the idea is we can, so that we can for example, we can have, let's say, dx divided by x squared, x4 minus 16. Now we can factorize the divided, 1 x power of 4 minus 16, we can divide into, remember that we have, if we have x minus a, x squared minus a squared, then equals x minus a, x plus a. So we use this formula, then that means we have x squared minus 4 square. So it's become 1 divided by x squared minus 4 x squared plus 4. That's we can have. This one is already definite positive quadratic polynomial. This one we can use again, become x minus 2, x plus 2, x squared plus 4. So this is the so the idea is, this is the power of 1, this power of 2. We can also, for example, the integral of 1 divided by x3 minus 2x plus, minus 8 dx, then we can have, x multiplied by x squared minus 2x minus 8 dx. Then we can x, now the x squared minus 2x minus 4 is x minus 4 x plus 2. Now, how do we separate? The idea is we are going to separate the polynomial so that if we have px qx dx, what we want is becomes integral of sigma integral of x minus a dx plus sigma of ax plus b x squared plus x squared c d, and this one x plus a square plus b square. Dx. So we are going to split. Let's say in the form of x minus the factor. This is a factor of x minus a. This is a factor of x plus a squared plus b squared. Now, this should be a. Now, how do we split from this one and a factor into the sum? Now, if we have x minus a, this is for denominator, then we can have a divided by x minus a. Now, if we have x plus a square plus b square, or definite positive quadratic square, then we can use ax plus b x plus a square plus b square. However, if we so for example, if we have 1 x minus a x plus a, then we can change to a divided by x minus a plus b x plus b x plus a, or sorry, it's b x minus b, sorry. And if we have x minus a and x plus, let's say, b square plus c square. Now for x minus a, we have a divided by x minus a plus, for this one, oh, sorry. For this square becomes x plus b square plus c square. Then this one is bx plus c. Now, if we have, let's say, x minus a power of 3 x minus b, if we have 3 power of 3, then x minus a power of 3 should be what? X minus a power of 2 plus x minus a. So this is the a, b, c, and then plus d, d divided by x minus b. So we have, if we have power of 3, then beginning with power, well, you can start with x power of 1 to 3 or 3 to 1, it doesn't matter. Now the problem now is finding a, b, c, and so on. So how do we find the idea is we equalize the denominator to the same as the original. Find the equalize denominator into the original. the original function. And then put the value or select value for let's say for variable for x, so that we can find A, B, C, and so on. Now the important is the selection of the value. For example, if we have x minus, let's say x minus x squared minus 2x minus 8, we know that the denominator is x minus 4x plus 2. And then we have, as before, we have a divided by x minus 4 plus b divided by x plus 2. So we equalize this one to x minus 4 x plus 2. So that means a can multiply with x plus 2 because we only have x minus 4, and for b we have x minus 4. Now that means the x now is equals to, well, it's not really equal at the moment, but it's equivalent to a x plus 2 plus b x minus 4. Now we select x to find a and b. For example, if we select x equals to minus 2, why is minus 2? Because if I select x minus 2, then it becomes 0. So it's, what we have now is minus 2 equals to, now is equal, and a multiplied by 0 plus b minus 2 minus 4. So it's minus 6. B equals minus 2. So b is minus 2 divided by minus 6, 1/3. Now we make this coefficient of b as 0. So we select x equals to 4. Then we have 4 equals to, now a 4 plus 2 plus b, now because x is 4, then is 0. So 6a equals 4. That means a equals 2 divided by 3. So that means x divided by x squared minus 2x minus 8 then equals to a is 2/3 x minus 4 plus b is 1/3 divided by x plus 2. Now if we oh sorry, one more, if to make simpler, the integral of dx divided by x minus a is ln x minus a plus c. So that means if we put the integral and the integral and so on until we have the integral here. So the integral of x divided by x squared minus 2x minus 8 dx equals to integral of 3 divided by x minus 4 plus 1 divided by 3 x plus 2 dx, then become 1/3 ln x minus 4 plus 1/3 ln x plus 2 plus c. So we actually factorize the denominator and then we split into the sum. This is the idea of another method for finding is we equalize the coefficient. Instead of using the value, we can also use the equalize the coefficient. So for example, we have x equals to, or this one equals to a x plus 2 plus b x minus 4. So it's become a plus b x plus a minus 4, sorry, 2a minus 4b and equals to, now x become 1x plus 0. So that means we have a plus b equals 1 and 2a minus 4b equals 0. So it's become linear equation, system of linear equation. So you can just from here you can find a and b. I think for this one, a equals to b, then 2b plus b equals 1, then b is 1/3, and a is 2 divided by 3, same as before. You can use the equalize the coefficient, or you can put the value. The result are the same. Now, if we have let's say integral of x squared divided by x squared dx. This the so x squared, this one become x minus 2 x plus 2, and this one x plus 2 x plus 1. So that means we have x squared divided by x minus 2 x plus 2 square x plus 1. Actually, it's faster if we put the value instead of equalize the coefficient. So this one becomes a divided by x minus 2 plus b divided by x plus 2 square plus c, because we have power of 2. So x plus 2 plus d divided by x plus 1. Now we equalize with the original. So it's become now is x minus 2 x plus 2 square x plus 1. Now A has x minus 2. So we need to multiply by x plus 2 square. X plus 2 square and x plus 1. For B, we have x plus 2 square. So we multiply with x minus 2, x plus 1. C has x plus 2. This is x plus 2 square. So that means C multiply with x minus 2, x plus 2, x plus 1. And plus D. D has x plus 1. So multiply with x minus 2, x plus 2 square. So we have this equation. X square A multiply with x plus 2 square, x plus 1 plus B, x minus 2, x plus 1, C, x minus 2, x plus 2, x plus 1, and plus D, x plus 2, sorry, x minus 2, x plus 2 square. Now the value is the value to be considered is, let's say, the root of the equation. So the root of this one is 2, minus 2, and minus 1. So try with the root. X equals minus 2. Try the root. X minus 2, so it becomes minus 2 square. Now, because x minus 2, then is 0. Plus B minus 2, oops, minus 2, minus 2 plus 1. For C, we have x plus 2, so that means becomes 0 plus 0. This one contains x plus 2, then also plus 0. Then what we have now is see, minus 4, minus 1, or sorry, for B equals 4, that means B equals 1. We have B as 1. So another root is x equals minus 1. So if x equals minus 1, then we have minus 1 square plus this one is 0, oh, sorry, is 0 plus, for B is also 0, for C is also 0, then for D minus 1 minus 2 minus 1 plus 2 square. So it's become minus 3 D equals 1, which is D is minus 1 divided by 3. Another root is x equals 2. So it's 2 square equals to A, 2 plus 2 square, 2 plus 1. And this one is 0. This one contains x minus 2 is 0, and also D is 0. So we have 16 multiplied by 8 is 40. Is it 48? A equals 4. So A equals 4 divided by 48 is 12. Okay. Now we have no more root, then try another. No more, so no more root. So try another value. Let's say x equals 0. If x equals 0, then 0 square equals to, now we have a is 1 for 12. Because of 0, then 0 plus 2 square, 0 plus 1. Plus, now b is 1. Now x0 is 0 minus 2, 0 plus 1. Plus c, this is minus 2, 0 minus 2, and 0 plus 2, and 0 plus 1. And then plus d, oh sorry, d is 1 divided by 3, multiply with 0 minus 2, 0 plus 2 square. Now we can find c because this one is 4. So 0 equals 1 divided by 3 plus minus 2 plus 1 is minus 2 plus c is minus 2 plus 2 minus 4 minus 1, so minus 4. Minus 4c plus minus 2 plus 4 minus 8, so minus 8 divided by 3. Now we can have 4c equals to, what's that? Minus 1, 3 plus 2 plus 8 divided by 3. So minus 1 plus 6 plus 8 divided by 3. So 13 divided by 3. Then we have, we have the integral of a is divided by x minus 2 plus b is 1 divided x plus 2 square plus c is 13 divided by 3 x plus 2, and d we have minus 1 3 divided by x plus 1. The x, so it's become half ln x minus 2. This one we use the formula. If integral of dx divided by x plus a power of n, then 1 minus n x, 1 minus n multiply 1 x minus 1 a n minus 1. So it's become minus x plus 2 plus 13 divided by 3 ln x plus 2 and minus 1 divided by 3 ln x plus 1 plus c. So this is plus a. Sorry. Okay, try. Oh, no, x plus 3. So this x plus 3 divided by, now we have x squared minus x minus 2 equals to x plus 3. Then it's x minus 2 x plus 1. So that means have x plus 3 divided by x minus 2 x plus 1 equals to a divided by x plus b divided by x minus 2 plus c divided by x plus 1. So we equalize the denominator, then x minus 2 x plus 1. So it's become a multiplied by x minus 2 x plus 1 plus b multiplied by x plus 1, because only have x minus 2 plus c x multiplied by x minus 2. So we have x plus 3 equals to a x minus 2 x plus 1 plus b x plus 1 c x minus 2. Now again, try the root. X equals 0, because this one is 0, this one 2, this one minus 1, the root. So we try 0. So 0 plus 3 equals to a 0 minus 2, 0 plus 1. And because 0, this is 0 plus 0. Oops. So we have minus 2a equals 3. So a equals minus 3 divided by 2. And then we try x equals 2. Then we have 2 plus 3 equals to 0 plus b times 2 multiplied with 2 plus 1 plus, because x equals 0 equals 2, then plus 0. So 6b equals 5. So b equals 5 divided by 6. And then x equals minus 1. So minus 1 plus 3 equals to minus 1. So it's 0. Minus 1 also 0 plus c minus 1 minus 1 minus 2. So minus 3 minus 1, so 3. C equals 2. So C equals 2 divided by 3. So we have the integral of x plus 3 divided by x minus 2, x plus 1 dx equals to integral of a, what is a, minus 3 divided by 2 divided by x plus b is 4, 6 x minus 2 and plus c is 2 divided by 3 divided by x plus 1 dx, so it's become minus 3 divided by 2 and x plus 5 divided by 6 and x minus 2 plus 2 divided by 3 and x plus 1 plus c. Yes. Well, it's as I said before, the actual is absolute value. Right? So if we later on talk about the definite integral, then it's become absolute value. Yeah, yeah. So this one is actually all absolute value. But maybe I'm too lazy to write. But as I think I've already mentioned that the actual value is absolute value. Right? So it's just because I don't want to write the absolute value then. But it is absolute value. Yeah. Sorry. No, it's absolute value. So if it's indefinite become a negative and it's a positive. Yeah. Let's say if I put that x equal, let's say 1, then we have ln 1, then plus ln 1 minus 2, then plus ln 2. So this one become ln 1. Because as I mentioned, that is actually absolute value. Last example, integral x divided by x squared plus 4 x minus 2. So x squared plus 4 x minus 2. Now, because this one is definite positive, x squared plus 4, then we have a x plus b. Plus, because it's just a linear part of 1, so x minus 2, and then it's c. So we can equalize x squared plus 4, x minus 2, So it become ax plus b, oops, x minus 2 plus c x squared plus 4. Now we have x equals to ax plus b, x minus 2 plus c x squared plus 4. Now the root, we try the root is, sorry, x equals 2. So we take x equals 2, then we have 2 equals to 2a plus, oh, sorry, it's a 0. 0 plus c 2 squared plus 4. So c is 2 divided by 8, 1, 4. Now we don't have any more real root. Now we try, then we have to find a and b. So let's say we take x equals 0. It's actually free. You can have any number except for the root. So you can have 1, 2, 3 minus 1 or whatever. Now why a 0? Because this one becomes 0, right? So that's why if I 0, then 0 equals to a 0, then it's become b 2 minus 2, sorry, 0 minus 2 plus, we have c 1 divided by 4, 1 plus 4. Oh, sorry, 0 plus 4. So what we have now is 0 equals to minus 2b plus 1. So b equals 1 divided by 2. Now we have a, c, and b. To find a, we can use a number. For example, let's say x equal 1. Then we have 1 equals to, if x is 1, is a plus b is half. X minus 2, 1 minus 2 plus 1 divided 4, 1 plus 4. So we have 1 equals to a, oh, sorry, minus a minus half plus 5 divided by 4. So a equals to 1, oops, sorry, 5 minus half or minus 1 minus half plus 4 divided by 4. So equals to minus 4 minus 2 plus 5 divided by 4. So it's become minus 1 divided by 4. Now we have the integral of x divided by x squared plus 4 x minus 2 equals to integral of a is minus 1 minus 4a, x plus b is half divided by x squared plus 4 plus c is 1/4 x minus 2 dx. Now, as I mentioned before, the integral of x squared plus 4 is 2x. So we have integral of 2x. Now, because we have minus 1 divided by 4, so that means we have to multiply with 1 divided by 2x, then we have to multiply with 1 divided by 8 to make it the same as minus 4x, then plus half divided by x squared plus 4, and we have this one is minus 4 ln x minus 2. Or we can plus c later on. So for the first, equals to 1 divided by 8 integral of 3x x squared plus 4 plus half integral of 1 divided by x squared plus 4, sorry, dx. This is dx plus 1 for ln x minus 2. And because this one is derivative of x squared plus 4, then it's become 1 divided by 8 ln x squared plus 4. And plus half integral of dx divided by x squared plus 4 is half arcus tangent x divided by 2 plus x minus 2 plus, ln x minus 2 plus c. And this is 1 divided by 4. This one. This one, definite positive. So the root of this is complex, right? Let's we call it definite positive. So if it's definite positive, the general form of definite positive is x plus a square plus b square. So this one, a is 0, b is 2. So this is the form of definite positive. So if definite positive, that because if definite positive, we cannot factorize into real. So because we cannot factorize into real, then we put ax plus b. Even if we let's say if we have 1 divided by x squared plus 4x plus 5, let's say x plus 1. Now x squared plus 4x plus 5 is definite positive because the root, this is the, if we use the ABC, this is 16 minus 20. So because it's a complex, right? So because it's a complex, then it's definite positive. So we have ax plus b divided by x squared plus 4x plus 5. Then plus c x plus 1. So the condition of this one, ax, is the denominator is definite positive. And then later on you have to change into definite positive is x squared plus 4x to make it this form, then it's just the plus. And this is because 1, this is plus 1. So it's become x plus 2 square plus 1. So this is the most or the maximum form in the denominator. Otherwise, just leave it. So this is the maximum of denominator is definitely positive. So for example, if I say, well, try x divided by x3 minus 2x minus square minus 7x plus, let's say 15. Well, we cannot factorize this one. So just leave it. Sorry? So if you integral this one, let's leave it because maybe it's difficult to factorize this one. So just leave it. And I'm not going to give you the proper method that you cannot factorize. Okay, we'll have more example next week. So thank you very much.